antibiotic resistance bacterial strains have been found in Antarctica ice core samples that were dated to be well over 1,000 years old, meaning antibiotic resistance has existed long before our discovery of antibiotics. Why care about antibiotic resistance, though? Well, antibiotic resistance poses a very real threat to the health of both animals and humans, and the amount of antibiotic resistance bacterial strains that are developing is rapidly growing with each passing year. But why am I credible to speak on the subject of antibiotic resistance to you today? Well, I have worked for many production scale operations involving animal care and management, most of which have included dairies and poultry production facilities. One of the number one leading animal health related issues that I've noticed on all of these operations has been the development of antibiotic resistance bacterial strains that have been developed as a result of antibiotic misuse on many of these operations. In this presentation, I will be discussing the brief history, the current status, and the potential future outlook of antibiotic resistance as it relates to the livestock industries. Let's begin with a bit of the history behind antibiotic resistance in livestock. Beginning in the 1940s, antibiotics began being used for animal growth promotion. In the 1940s to 1950s, penicillin resistance in bacteria grew to as much as 50% of hospital-related infections. During the 1960s, multi-drug resistant salmonella strains were being identified all over the world. And in 1969, antibiotic resistance bacterial strains were identified in many sectors of the poultry industry, affecting not only workers in the poultry industries, but also the animals themselves. In the 1970s, the European Union began banning certain antibiotics, such as tetracyclines, which are very commonly used antibiotics, for growth promotion in the livestock industries. In 1985, Sweden banned all use of antibiotics in animal feed, and in 1998, the Danish food industry banned all use of antimicrobials, also known as antibiotics, for use within the livestock industry as growth promoters. In 2005, the United Kingdom identified various strains of LA MRSA, which is an acronym that stands for Livestock Associated Methicillin Resistant Staphylococcus aureus, which is a lot of big words that basically mean that a specific and very common strain of bacteria have become resistant to a very commonly used antibiotic. In 2006, antibiotics used for livestock growth promotion were completely banned in all European Union participating states. And in 2007, India began banning certain antibiotics, such as chloramphenicol, for use as livestock growth promoters. In 2007 as well, Mexico began banning most of their antibiotics that are used for livestock growth promotion. And in 2011, South Korea began banning most antibiotics used for livestock growth promotion as well. In 2013, China used 84,200 tons of antibiotics for livestock use, which is one of the highest recorded amounts and purchases of antibiotics that are used for the livestock industry in any particular country at any particular point in time so far. In 2013 as well, the Food and Drug Administration published voluntary restrictions on antibiotic usage in livestock production. However, these regulations were non-binding and completely voluntary for livestock producers. In 2014, the United States Department of Agriculture created the Antimicrobial Resistance Action Plan, which began tracking and tracing antibiotic resistance in microorganisms in the United States. So, what about the concurrent state of antibiotic resistance in livestock today? Well, antibiotic resistance in bacteria have been reported in food animals and their products all over the world. Some countries, especially those with few regulations and are developing countries, such as Pakistan, are having rapidly increasing levels of antibiotic resistance in bacteria present in food production animals and their products. However, improvements in animal management, hygiene, and housing have reduced the prevalence of disease and the overall need for antibiotics. Milk samples, for instance, from Tanzania were reporting antibiotic resistance in the microflora present in the milk, mainly as a result of poor hygiene and animal management. Antibiotic resistance bacteria have also been reported not only in the animals and their products, but also in the environments, soil, and manure present on many farms. Even antibiotic-free farms still had a decent amount of antibiotic resistance present in their microbial flora on their farms. However, it was also found through that exact same study that a lot of the testing methods, and of all of the testing methods, that high throughput quantitative polymerase chain reactions, or HT-qPCR, was identified to be one of the most effective methods for detecting antibiotic resistance in microorganisms in farm samples. However, multi-drug resistance bacterial species are still being reported all over the world, even in places such as Portugal. A growing concern to this day is zoonotic transmission of antibiotic resistance from animals or the environment animals have been in to people. This occurs mainly through three means. That is through horizontal transfer of genes, which is where genes present in the environment from other microbes who have died can be taken up by concurrent microbes and gain antibiotic resistance. It can also be spread through bacteria being consumed or being causing infection in people and animals. And even consumption of antibiotic residues or just the antibiotic resistant genes themselves in many cases can also result in antibiotic resistance infections. So what does the future look like for antibiotic resistance? Well, it has been predicted that antibiotic usage is going to need to increase by 67% by the year 2030. And there are many people and countries who are considering applying a global ban of antibiotics used for animal growth promotion. Antibiotic misuse is so far predicted to cause more antibiotic resistance in the future. And more research needs to be done on antibiotic resistance in microorganisms to understand how to better prevent antibiotic resistance from spreading, but also learn how to address the situation concurrently. There have been alternatives that have been discovered for treating and preventing bacterial infections in food-producing animals without actually having to use antibiotics. Some of these alternative treatment methods have included the use of prebiotics, probiotics, certain enzymes, certain organic acids, such as acetic acid, certain bacterial-produced proteins that have sort of an infectious agent to them, bacteriophages, which are individual viruses that attack and kill bacteria. Plant extracts can sometimes be used, and zinc oxide is a very common one that has been used. However, there is some debate as to whether zinc oxide is effective, as it has been widely used for many years as an antibiotic substitute or supplement in many industries, such as the swine industry. So overall, the history of antibiotic resistance, it has been mainly caused due to antibiotic misuse, according to many of the authors used for this presentation. But the driving of antibiotic resistance has occurred for many years, ultimately. The current state of antibiotic resistance is that it is still being reported in farm animals and their products, and even antibiotic-free farms who have been antibiotic-free for 5 years or even more than that are still having issues with antibiotic resistance. There is potential zoonotic spread of antibiotic resistance from animals and the environment where animals have been to humans, especially to those humans in whom are in direct contact with food-producing animals who have been treated with antibiotics. And what does the future look like? There looks like there's going to be a need for more antibiotics to be developed and an increased production of concurrent antibiotics. There is also potential alternative solutions for treating bacterial infections and also preventing bacterial infections as well, without actually having to use antibiotics. So here are some different sources that you can use as launch platforms to learn more about the mechanisms behind antibiotic resistance in bacteria, and also learn about various labs and universities where you can send pen samples or soil samples or animal tissue samples to be tested for antibiotic resistance. So today, as I conclude this presentation, I would like to challenge you all as producers to evaluate your current antibiotic usage on your operations. Are you using antibiotics according to legal requirements and your veterinarian's recommendations? If you are having problems with antibiotic resistance or inefficacy of certain antibiotics on your operation, consider sending in animal tissue samples or even pen soil samples to a lab for evaluation of antibiotic resistance. This can help you, as a producer, identify what antibiotics the bacteria on your operation are concurrently resistant to, and what type of antibiotics can be effectively used on your operation.